Hey folks, welcome back. This is part 2 of making the Edge-lit Acrylic printed circuit board. In the last video, we figured out how to set up a library and how to place components and how to connect all of the components. But this is still just a schematic. We haven't actually made our printed circuit board yet. So in this video, we are going to be converting this to a printed circuit board. And it's actually going to open up a completely different version of this program called Diptrace. And yes, you want to use the schematic rules from this. And here we go. So, we have all of our old components in here. Our battery, our switch, our resistors. Everything looks a little different though. So what this part of the program is doing is we're actually making like little pads of copper and we're tracing copper lines in between everything to make our own little circuit board. So what we really need to do is orient everything so that all of these blue lines that are coming everywhere make sense and don't cross over themselves when they aren't supposed to. So what we really need to do is lay this out so that all the components make sense, so that they all fit on our board, and that they all point the right direction so that everything actually is going to work in the long run. So step one, before we even start moving some parts around, let's set up the size of our board. So to do that, go to Objects, and you could place a board yourself, but we actually have really specific sizes of copper to fit this project, so it's easier to go to Board Points. And you want to create a rectangular board, and this one is 2.75 inches wide by 1 inch tall. And if you just hit OK, you should have a nice little purple board that pops up here. Okay, I'm going to reference my other boards that I've made here. I've got 8 of them on a page, so I can print a whole bunch off, just so that you can see what this looks like, or at least what we're aiming for in the end. So here's our battery, here's our switch. So basically power comes through the switch once you open it up. Power then goes to 3 different resistors, and then through the resistor to this other pad here, which then goes through one LED through the second LED. And then what this big white area is actually the ground for this entire project. So there's a common ground to everything. It goes underneath the resistors all the way around the side and everything like that. And it goes back to the battery terminal here. So we have 3 little mini circuits that all need to connect to that point of the switch right there. So let's go back to this. The way that this project is set up, we have a couple of mounting holes for screws on the top corners here. So why don't we start with that? Actually, the first thing that you should do, instead of going on all of the components, again, you should go to Highland Parts, that library that you set up in the last video. If it's not there, I'm pretty sure it should pop up, but if it's not, then you need to go to Library and set up your library as per the old video. In the basic parts here, you're going to find a single pad connection. I think that's the best one that we've got for this. So a single pad connection, and let's just plunk these just in the corner here. And what these are actually there for is just it's a hole to drill a hole through. It's just to make sure that we leave the space for that screw hole and don't put any components in the wrong place. If you want to try to pick your parts up now, that's not going to work. You're just going to keep making more holes. So get back to the default mode on the mouse here, and now you can start actually dragging things around. So the positive side of the battery here is on the left. I actually want that to be on the right, so I'm going to hit spacebar twice, and then that moves that positive side over, and I'm going to put this up near the top up here. And the switch, let's move that one over. So you see how this blue line is going from one side of the battery to this other side of the switch. Really doesn't matter which side of the switch you connect it to, but we're trying to build our printed circuit board to follow the rules of our schematic that we just made. So try to keep these blue lines nice and straight, and very importantly, don't have them crossing over each other. Now I'm literally just going to start clicking and dragging certain parts around. So you'll notice as I highlight this pad here, it highlights in red which ones it needs to be connected to. So this gives me a good indication. I have 1, 2, 3 resistors that I need to connect to this one red pad here. So let's start dragging these over. I'm going to flip you this way. I'm going to drag you over, flip you that way, and drag you over, flip you that way. This video is just going to have a lot of clicking and dragging and basically maneuvering parts to the right place so that so everything fits. On the working version of this, I have all of the LEDs lined up fairly close to the bottom edge here. And this is because we're mounting it on the top part here, and these LEDs actually end up being in the middle of our part. So we need to set those up in about the same place as well. I'm going to use as much of the board as I can because I want these LEDs to be spaced out as best as I can. And I'm just going to sort of put them in a basic location for now. Maybe I should be rotating them as I go, just so this doesn't get confusing. The flat side is the negative side. Oops. And I want all of the negative sides pointing to the left so that it connects to this part of the battery here. So all the power's coming out the right side of the circuit, all the grounds are coming through the bottom side here. And this one, that makes a little more sense like that. Bring this one over. And if you're needing to be precise about where all of these go, there's a grid that helps you set up where everything is. I just basically count the grid lines and just sort of evenly space things out by the grid lines. So this LED has 2 little dots before it hits the edge, and it's got 4 little dots between them. Let's do the same over here. So I wanted 2 little dots by the edge, and then 4 little dots in between them. And then I'm just going to split the difference with these middle 2. That looks about right. That looks about right. Maybe one over. Hey, that looks like it. Perfect. Good. One of these blue lines is crossing over where it doesn't need to be, so I'll need to figure that one out. Okay, I'm going to put these resistors just a little bit further away because once we start actually installing these components, you don't want the resistor, like one pad of the resistor, to be sitting underneath the LED. So the green outline is basically like how big the part actually is. And the big round pads that you see on the outside is what's going to be filled in with copper, and which we're going to be connecting with some solder. So let's move this to maybe about here, so it's way out of the way of those 2 LEDs. I'm going to move this one so that it's way out of the way as well. And let's put you, how about there? Maybe the battery moves a little bit so it's out of the way. Really doesn't matter at this point. Okay. So now what I want to do is I want to start connecting everything that has the blue line and it wants to be connected. So the basic way of doing this is to route everything manually with this button here. So click on pad 1, click on pad 2. Cool. So there's our little copper trace connecting one piece to the other. I could connect these 2 as well, and as long as everything highlights red, everything's still good. We're good to go. Do another one over to here. Voila. If you're curious, maybe something's about different than mine than it is on yours. Maybe my traces are thicker than what they are on yours. Under route, so we're making routes here. Go to the route setup, and you can tell it how wide you want all of these traces to be. So I'm at 0.08 inches. I typically tend to go nice and wide with these. The default is really small because usually when people make circuit boards professionally, they have a very fine-tuned way of doing this, and they want to try to minimize the material that they use. But I'm basically making the copper board fit the project, and I want these traces to be as wide as possible because our etching process is imperfect, if you want to put it that way. So a trace width of about 0.8 inches I find to work quite well. There's another option that we could do here. If you don't feel like running all of these routes yourself, what you can do is do the run auto router. And there we go. So it just plonked in a whole bunch of routes for us. The thing is, it's connected everything in a way that makes sense to the computer, but maybe it doesn't actually make sense in like real life. So as an example, this is good. These are all connected. This connects to this, connects to that. That's fine. Okay, this ground here, it really shouldn't be so close to this powered trace here. And it really shouldn't go underneath this trace because we don't have a 2-sided copper board. It's just a 1-sided copper board. So I would actually just undo that. For a circuit board this simple, just run all of your traces manually. This is actually probably going to go quicker than running the auto router. So what I need to do is connect this to that one. Of course, I don't want to be, that's the negative pin of the LED, so I don't want to be cutting over top of that. I want to make sure I give it plenty of space. This one needs to connect to there. This connects to this one. This connects to this one. There we go to that, and this goes to that. Now I haven't connected any of these ground wires together yet. Let's go on a big looping path all the way around the outside. One to there, and then another one. Let's go way out of the way to make sure that we aren't cutting into anything. That's actually pretty close. Let's go down a little further, all the way to the bottom of the board to connect there, and another one to connect those last two blue lines. That's weird. Right there. Perfect. Okay. So this would be a working circuit board. But there's a couple things, there's one extra little thing that I want to do to this. So before I go too far, if this is working, I'm going to hit Save As. I'm going to save it as, let's call this Edge-lit Acrylic, 6 LED, PCB, something like that. And hit Save. Wherever you want to save things, I would suggest saving things in your OneDrive. Maybe make a folder for this kind of stuff. Okay. The next thing that I want to do is I want to do this thing called a pour. And the reason for this is, think about this in terms of like copper and copper that needs to be removed. So our etching tank is filled with a chemical that combines with the copper on these boards, and basically the two glob together and fall off the board. And the places that are covered, like this, which we're going to print in ink and press onto the copper board, which will cover it, is going to remain copper after half an hour or so, after this etching fluid, removes everything else on the board here. So here's the thing, this etching fluid's expensive, and pretty much this, like almost the entire board, needs to be etched away, which is quite wasteful as far as that chemical is concerned. So the way to get around this is that we want to do a pour, and similar to these other ones here, I actually want most of the board to remain copper so that we just don't use as much of that material. So what I want to do is I want this ground wire here to actually be a part of the pour. So like you'll notice that's the pin of the last LED, 1, 2, and 3, and here's the pin of the battery. And this actually makes it easier to solder the whole thing together in the long run. So the pour button is right here. We want to place a pour. Strangely enough, they make you like draw a box around the area that you want poured. Whatever, cool, there we go. And for the last one, just right click and hit enter. And then this menu should show up, okay? So as we're pouring, you want to pour with a solid, color. And you want to give it plenty of clearance. So I find it about 0.05 inches tends to work because the space in between the pins of the LED here is a little bit less than that. So if you start going too much lower, you actually end up too close. And for connectivity, here's the thing. If you want to connect it to your ground wire, we need to connect it to the last net that we've made, assuming that your last net was those ground ones that you made. So for me, that would be net 8. If you're not sure what it is, you need to just basically highlight the net and it will show you. And let's hit OK and hope this works. Yeah. I would say that almost worked. Something's connected, which is really not supposed to be. Those two are not supposed to be grounded together. So I think I got something wrong. Let's go back, Control Z to go back one step. Why would that be included in the pour? That doesn't make any sense to me, unless I didn't run a route right. Those two are connected. Those two are connected. Those are connected. Okay. Oh, this is net 4. Well, that makes far more sense. Okay. Try this again. Copper pour. Maybe check which net it is before you do this. And everything's all the same, except we want to connect this to net 4 and hit OK. That looks more appropriate. Okay. So, Our little pads here are not connected to ground so that we don't like accidentally ground everything to the box. Positive side of the battery gets broken by the switch. Power comes through, 3 resistors. Power goes through to the positive side of each LED. Power keeps going through to the other LED and then gets grounded out all the way back to the battery. I think we got it. Okay, so I'm going to hit now Save As, and I'm going to call this one the poured version of this, because this is the one that I actually want to print. So before you print this, I have a couple of suggestions. Number one, give me a call, because we need to put a special paper in the printer, and I don't leave it in the printer normally because it's expensive paper. So if you try to print this, it's going to print on normal paper and the whole thing's not going to work. Thing number two is that you should probably make more than one version of this, because there's a decent chance that something's going to go wrong, and we want to do this again. So if this is expensive paper, we may as well print 2 or 3 of these so that we have one ready to go. So just grab everything and hit Control-C to copy it all. And make sure you're on the mouse selecting tool. Actually, just drag everything over for a second or drag it down. And then hit Control-V to place another one in. I don't think I got everything there. There we go. There's a weird thing about this program that as you paste another part in, I'll do it now, and it looks like everything's selected, you don't actually get the like the outline of the box with it, and you need to drag everything back up to it, which is a little bit awkward. So I would say, like, grab at least 3 of them, put them in a line like so, and go to Print Preview, and make sure they're on the page, for one. And number 2, our components are actually also getting drawn in here, which we don't want. Everything that gets printed, if you can imagine it, is going to end up being copper in the end. And say here where the switch is, you wouldn't want a copper line connecting both sides of the switch, because then it would short circuit all the time. So if you click on Objects, and I believe it's the silk that you want to take off, which tells you where, like, that's all of the components that would be there. And this leaves just exactly the circuit board that we're looking for. So when it is ready, when you've called the instructor and you make sure that you've got the right printing paper in there, hit print, make sure it goes to room 105, and hit OK. And that's the printed circuit board. The rest of it's going to be an in-person demonstration, because from this point on, this circuit board needs to get pressed on the t-shirt press, and that's far easier to show you in person. So I'll catch you on the next one.